it won't talk to me.
I'm busy right now. Trying to.
Well, you sit still for 5 seconds. Why don't you just get on a ceiling fan and just go round and round in circles? All right. Y'all should be able to see my screen. There's 1.7/5. I don't think we've done these, but we could have. Heck, I don't know. I've done so many dadgum problems last week. I don't know if I've done it or not. So here's the function f of x is equal to the square root of 3 plus x over 2 minus x. And that's going to be 3 plus x over 2 minus x to the 1/2 power. And that's going to be 1/2 3 plus x, 3 minus x, 1/2 minus 2/2 with the derivative of 3 plus x over 3 minus x. And that's going to be 1/2 times 3 plus x over 3 minus x to the negative 1/2 times the denominator times numerator prime minus the numerator times denominator prime all over the denominator squared. I have a feeling we've done this, but I don't mind doing it again. And that's going to be equal to 1/2 3 plus x over 3 minus x to the negative 1/2. And this is going to be 3 minus x times 1 minus 3 plus x times negative 1 all over 3 minus x squared. And I'm going to take this negative 1 and I'm going to multiply it by this negative 1. That's going to give me positive 1. So that should cancel this out. So you're going to get, well, you're going to get equals 1/2 3 plus x over 3 minus x to the negative 1/2. And that's going to give you 3 minus x plus 3 plus x over 3 minus x quantity squared. And those x's are going to cancel. You're left with 6. So I'll put in one more line down here. Equals 1/2 3 plus x over 3 minus x to the negative 1/2 times 6 over 3 minus x squared. I'm going to put that on the next page. Equals 1/2. We could flip this in the middle, but I'm going to do this. I'm going to do 3 plus x to the negative 1/2, 3 minus x to the negative 1/2 times 6 over 3 minus x squared. And of course, I'm going to try to get a common denominator, or I don't have to get a common denominator because we're not adding. So you could actually multiply this out if they want you to. I don't know. It's going to be 6 times 3 plus x to the negative 1/2 over 2. These are the same, so it's negative 1/2 plus 4/2 is what? 3/2? Somebody check my math. That's negative 1 plus 4/2. That's 3/2. So 3 plus x to the 3/2. And you could actually bring this down, and that would be 3. Bring this down here. That would be 3 plus x to the 1/2. Okay, this is minus. Sorry. I don't know if they want to do that or not. I'm gonna say I don't know. 6 divided by 2 is 3. So I get 3 over 3 minus x to the 3/2. 3 plus x to the 1/2. Now it could be any derivation of that answer. So let's see what they got. Five over. They got a 5. And I got a 3. That's great. Well, I see the 2. There's a 2. 3 plus x to the 1/2. 3 plus 3. 2 minus x. Where'd they get the 2? Oh, I think I changed the problem midway through. Yep, I sure did. I suck. Well, you see how to do it. I changed the 2 minus x to 3 minus x midway through the problem. And of course, not one single person said a word. So thank y'all. Appreciate it. Thanks a lot. That would be why I got a 6 instead of a 5, because 2 plus 3 is 5, and 3 plus 3 is 6. So y'all see where I got the error. Right here. Right here, that would be a 2. Because I should have 2 minus x right here. And a 2 minus x. That would have fixed everything. So anyway, that's how you do it. So that would be a 5. And there's the 2. And this is supposed to, one of them is supposed to be 2 minus x. I think this is supposed to be a 2. But I appreciate y'all's feedback on that. Thank you for catching it. I really do. And communicating. Thank you. We're doomed. All right, next. 1.8, 19/12. 1.8, 19/12. 1.8, 19/12. And this is, they want f double prime, so f of x is equal to x squared plus 5 raised to the 5th power. And that's going to be f prime of x is equal to 5 x squared plus 5 to the 4th. times 2x. F prime of x is equal to 10x. X squared plus 5 to the fourth power. That's first derivative. Second derivative, f double prime, is equal to 10x times 4, x squared plus 5 to the third times 2x. And then 2x times 10x is 20x squared times 4 is 80x squared. I don't know why I'm asking y'all, because y'all wouldn't tell me if I wrote down the wrong number or not. 80x squared times x squared plus 5 to the third power. That's what I got for the double prime. And they didn't get that. Wow. I don't know how I got that wrong.
They are very particular about how you answer things.
No, they shouldn't have. I don't know how. They should have 80 there. Okay, I did something I did something way crazy, because at least Miss Gammon got a 40. They just got a 10. 2x times 5. No, I don't understand how they did. They don't even have an x. So we must have done something wrong. I'm going to do it again. Y'all settle down with the feedback. F of x. Let me make sure I wrote down the problem right. F of x. They want f double prime. X squared plus 5 to the fifth power. F single prime is 5 x squared plus 5 to the fourth power times 2x. 2x times 5, last time I checked, was 10x. Times x squared plus 5 to the fourth power. That
Professor, I think you're supposed to find the second derivative or whatever. It's got two.
I got to do the first derivative first. Right?
I don't know why it's wrong.
I'm sorry, what?
I don't know why it's wrong then.
I don't know. It doesn't make any sense, because even right here I get 40. But they're saying it's supposed to be 10.
I think you have to do the product rule too for this second time.
Yes, you're right, because that is because you've got an X. Thank you. Thank you very much. Thank you for the communication. 4 times 10x times x squared plus 5 to the third times 2x. There it is. God, that's a mess. And you got to do, these two are multiplied together. So you should be able to do it. I'll do it anyway. F double prime of x is equal to 4. And that'll be first times the derivative of the second plus the second times the derivative of the first times x squared plus 5 to the third power. I still get 40x squared, or I don't know. F double prime of x is equal to 4. That's 20x 20x. I've done it 2 different ways and still got the same answer. Four times, let's see, 20x plus 20x is what? Well, I got a little bit different answer. F prime of double prime of x is 20 plus 20 is 40x. So that'd be 160x times x squared plus 5 to the third power. I don't know what they're doing on this one. And then they got another, I don't know what they did here. I really don't. They did the chain rule right there. Unless they're saying, they could be saying you got to do the product rule here. Let me see if that's what they're doing. This is one of those tricky dicky problems. I'll try that and see what that does. F prime f of x is equal to x squared plus 5 to the 5th power. I'm going to do this one more time. I'm not doing it after this. F prime of x is equal to 5 x squared plus 5 to the 4th power times 2x. And this is where I think they're getting the first times the derivative of the second. 2x, that'd be 10x, x squared plus 5 to the 4th. This is where they're doing it, I think. Now, I may be wrong. This is one of those problems that are like a little tricky. F double prime of x is equal to first times the derivative of the second, x squared plus 5 to the 4th prime, plus the second times the derivative of the first. Well, you should get the same answer. F double prime of x is equal to 10x times 4 x squared plus 5 to the 3rd times 2x. That's what I got before. Plus x squared plus 5 to the 4th times 10.
New Facebook comment.
F double prime of x, 10x times 2x times 4, 20x squared, that'd be 80x squared. Somebody help me out. 2 times 10 is 20. X times x is x squared. I got 80x squared. X squared plus 5 to the 3rd power plus 10 x squared plus 5 to the 4th power. Huh. They got 10. I don't know how they got what they got. I've done it 3 different ways, and I think this one is correct. But my first one, I got 80x squared. I got the first part right here. And they got just that one little 9x. Where the hell did they get the 9x squared plus 5? All right, we're gonna see what they're doing here. That's gonna be, I don't know if they want me to type in five parentheses, x shift up squared plus 5, close parentheses, to the fourth power, to the fourth power, and then times 2x, well, that'll be 10x, right? So 10x, okay, that should be the first derivative. That's what I did. I'm gonna do it one more time. They said that the first derivative was correct. So that'd be 10x times x squared plus 5 to the fourth power. First times the derivative of the second. 4x squared plus 5 to the third power times what? 2x. First times the derivative of the second plus the second times the derivative of the first. First 10x, and they're going to take the derivative of all that, so I'm not going to fill that out, so I'm just going to hit, but I am going to do mine over here. That's going to give me 20x squared times 2 is 80x squared times x squared plus 5 to the third power. Can somebody tell me what 2 times 4 times 10 is? I thought it was 80, but hell, I don't know now. 10 times x squared plus 5 to the fourth power. Okay? And I know that's not what they're going to get. If they're going to get it, they must have done a lot of algebra to get the answer to come out like it is, because they must have done a lot of stuff afterwards. Oh, they're doing it step by step. 10 yeah, that's what it is. They're factoring out. You got to factor out an x squared plus 5 to the third power. And 10 will come out of that. So 10 parentheses x squared plus 5. So we did the math right. We did that. We did the calculus right. X squared plus 5 to the third power. They're going to factor that out. They factored that. They factored out. There it is. And that leaves that. Okay, they did algebra afterwards. That's what they're doing. I didn't know they wanted to go all that far, but that's what they're doing. They factored out. And whoever sent this question, that's what they're doing. They're factoring out a 10 and an x. So factor out 10, and that's going to leave an x squared plus 5 to the third power. And that's going to leave 8x squared plus x squared plus 5 to the first power. I think. And that's going to be 10 times x squared plus 5 to the third power. And x squared plus x squared is 9x squared plus 5. That must be what they did. So they did a little bit more algebra. This is the derivative. And they factored out and did algebra. That's what they did. So I can understand why you were confused on that. Okay, I would have not asked you to go with more algebra. I would have stopped right there. Miss Gammon, did that help? I hope I didn't confuse you too much. That's a tricky question. I don't know if she's even
Yeah,
in
that
here.
helped.
What?
It helped.
Well, I can see why you sent it. It's kind of a
Yeah, it's
tricky question.
confusing.
All right, now let's look at the slides for today. I went ahead and pulled the slides because I know we touched on a little bit of the, and they already kicked me out of the, great. So let's go ahead and look at the natural log and all that good stuff. Now remember, when you're talking about natural logs and talking about logs, you got to remember that your calculator will only be able to do two types. It'll be able to do log base e, which is natural log, and log base 10, which is equal to log. Okay, so these are the only two that are calculatable in your calculator. Also, you need to remember that the change base formula says if you have the natural log or the log base 2 of 5, that you have to put it in the change base formula, log of 5 over log of 2, and that's base 10. You can do natural log of 5 over natural log of 10, 2, which would be log base e. So you got to remember that. That's the change base formula. Change base formula. You also got to remember E. We're fixing to get into E, which is E to the 2.7 is equal, E is equal to 2.7 something. So let me get there right quick. Then we'll go over the interest. E, where is E? Somewhere in here they gave you E. There it is. E is equal to 2.718. Write that down. And you can write the whole number down if you want to. They kind of give you a little bit of algebra and a little bit of calculus in these first couple of sections to kind of, I guess, knock your memory loose of natural logs and regular log and E. So they also give you a little bit of continuous interest versus compounded interest. So we'll do that. Compounded interest versus continuous. Compounded, A is equal to P, R, 1 plus R over N raised to the NT power. PERT, A is equal to PERT, PE to the RT. Those are your two exponential formulas that you're going to be seeing. And we know that P is the principal. That's what you put in. We know that R is the rate. Usually it's in a percent given in the question, and you have to change it to a decimal. N is the number of times it is compounded, it will say quarterly, daily, yearly, annually, semi-annually, monthly. N is equal to 12 with monthly. So number of times compounded. And T is the number of years. Now be careful here. What if I tell you 6 months? Would you put in 6? What if you put in 0.5? So right here, I want you to put a note. 6 months is equal to 0.5. Help you remember, if they give you 9 months, then that's 0.75. Okay? They give you 3 months, that's 0.25. So number of years. Same thing over here. P is equal to what you put in. It's called the principal, but I never can remember how to spell it because I always thought principal, P-A-L, was your friend at, the school, the principal. But they spell principal with a P-A-L and it messes me up. So I just say what you put in. E is 2.71, but it stays in the calculator as, in the calculator as 2. Blah, 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 blah. And then R is equal to your rate. And usually that's a decimal. And T is number of years. Now, the main thing about these two is make sure you understand how to use your calculator because it's very simple. I'm going to give you a problem here and make sure you can do it. Let's go with, there we go. Go ahead and write that down. Oh, there you go. Lewis invests $5,000 in an account that earns interest at an annual rate of, compounded continuously. Find the future value of Lewis's account after 5 years of interest is compounded continuously. So P is equal to 5,000. And yes, this is a test question. Compound and continuous is a test question. And 0.0325, so rate is 0.0325. And Y, or T, sorry, T is equal to 5. So A is equal to PERT. A is equal to 5,000. E supposed to be to the RT, sorry, which is 0.0325 times 5. So you take your handy dandy calculator, which I do not have up anymore, of course. Well, while y'all are typing it in, I'll be pulling mine up.
Hey, I'm gonna go ahead and I'll watch the rest of this later.
Okay, be that way then.
All right, I'll see you Thursday.
All right, see you.
All right, thank you.
I ought to be like those other teachers and have a fit. What do y'all think? Y'all ain't gonna say nothing. Just eat your carrot, drink your water. Clear. Second, quit. All right, so we've got E. That's going to be second. E to the point, parentheses, 0.0325 times 5. Close parentheses, enter, times 5,000. So at the end of 5 years, he's got 5882.24. Problem is, you can't find a bank to give you 0.02% now. Banks are not giving anything on savings account. So you'd be better if you did win any money to basically put it in stock or land or hold it yourself, because the banks aren't paying anything unless you get an IRA or a, something like that. So now it's like 0.02%. So you're not going to make anything off of it. Now, compounded continuously, or it's going to give you the same thing, but I don't know if they've got a example in here of, let's see, compounded continuously. Let's see, I don't think they've got, let me look up here and see if they got another one. No, that's continuous. That's continuous. No. All right, there is the properties that I gave you the other day. There is the product rule. There is the quotient rule. There is the power rule. There is natural log of E is equal to 1. And we do not take the logarithm of a negative. But there is one that they need to show you before they show anything, and that is, and I'm going to write this in red, because if you don't memorize this guy, you ain't going to have any, you don't need to worry about the rest of them. And that is the definition of a logarithm. Y is equal log base A of x. And that yields both ways. A to the y is equal to x. Now right there, you better put to memory, because it can help you with rewrites. It can help you with solving an equation, solving a logarithmic equation, and it can help you with turning a exponent into a logarithm, or a logarithm into an exponent. So it can help you with many things. So make sure you understand the definition of a logarithm. So I would say that would be number 1. This is number 1. And then the rest of them, number 2, number 3, and so on. They're going to give you some examples on this. And like I say, 2.1 and 2.2 are going to kind of be algebra and calculus. So they're going to try to, review a little bit and then throw the calculus on you. Right now, we're in the review. There's the definition of a logarithm. And log of m over n is equal to log of m minus n. That's the quotient rule. And log of m times n is equal to the log of m plus the log of n. And log of m to the n power is equal to n times the log of m. Okay, so there's number 1, there's number 2, number 3, and number 4. The change base formula is in there also, number 5. Change base formula. And I just do numbers. I don't really do. So if you have log of base 2 of 3, then that's going to be log of 3 over the log of 2, where log is base E or base 10. And that would be your answer there. So again, this is the second time that I've given you this. I sent you a file. Let's see, when was that? Was that last week? Last Thursday? What was it called? There it is. I'm giving you this so there won't be any, I didn't get it. My dog ate it. There it is. Exponents, logs, and properties and derivatives. Okay. Now they're probably going to give us a couple of examples of how to go from a exponent to a logarithm or rewrite, one of the two. There's another property. There is the change base formula. Natural log of e to the x. We'll get to that. And these, they want you to do the properties. And I'm just going to show them to you because this is kind of a review. Log of 6 is 3 times 2, right? So that would be the log of 2 times the log of 3. So it'd be the log of 2 plus the log of 3. And then you punch that in the calculator. And that's your answer. So you use the product rule there. Is it important for you to know the names of these rules? Yes or no? Yes. You don't want to walk into a calculus or Calc 2 class or whatever and say, that's there where you take that number and you move it over there to the right and you throw it up there to the right-hand side. You want to call it the product rule. I don't know why they don't call it the product rule, but anyway, this is the product rule. What is natural log of 81? Well, that's the natural log of 9 raised to the second power. So we can do the natural log of 81. And anytime you see 81, you think of a perfect square. So I'm going to rewrite natural log of 81. I'm going to rewrite it as natural log of 9 raised to the second power. And by the power rule, I can bring that 2 out front. And the answer is 2 natural log of 3. So you would punch that in the calculator. These are rewrites. They're pretty basic, but they're rewrites. Now they're doing 3 to the 4th power. I did 9 to the 2nd power. It's whichever one you want to do. And I would get 2 natural log of 3. Oh, natural log of 9, sorry. Natural log of 9, which is 3 to the 2nd power. You can do it however you want. All right, what about this one? That's the quotient rule. So that's going to be natural log of 1 minus the natural log of 3. And again, this should be like, oh, okay, I remember doing that. Natural log of 2 plus natural log of e to the 5th. That 5 will come out front. The natural log of 2 plus 5 natural log of e. And natural log of E cancels, and that gives you just 5. This right here is a base property. Log of 3 over the log of 2. Change base property. Okay, what else we got? Find the domain. Find the domain. 5 minus 2x. You can't have anything below 0. So in this case, you set the inside the parentheses equal to 0. 5 minus 2x is equal to 0. Negative 2x is equal to negative 5. Divide by negative 2. X is equal to 5 halves. Now 5 halves will give you a 0. And you can take the natural log of 0, but you can't take the natural log of a negative. So what's going to give you a negative? Anything bigger than what? Anything bigger than 5 halves, probably. Let's see. Here's a number line. Here's 5 halves. So what's below 5 halves? Well, 0. And what's above 5 halves? 3. So let's see, 2.5, right? So let's plug in 3. What's 5 minus 6? It's a negative. So anything above this is going to give you what? Negatives. 0 is going to give you positives. So the domain is, you have to use everything below 5 halves. So x is less than or equal to 5 halves. That's your domain. Because you can't have negatives. Negative infinity to 5 halves. And again, this is all review. Same thing. I'm not going to do that one. I'll let you do it. Just set it equal to 0 and tell me what will give you a negative. E to the 3x is equal to 2. Take the natural log of both sides. That's a little bit of review. So if you have e to the 3x equals 2, anytime you have e, anytime you're given e, anytime you see e, you need to think natural log, because natural log will get rid of e. Natural log of e to the 3x is equal to 2. Natural log of e goes out. That 3x comes out to the front using the power rule. 3x times 1 basically equals 2, and x is equal to 2/3. Again, that's review. You should, be okay with that. There's what we just did. Oh, I didn't take the natural log of both sides. Sorry. So natural log of 2 over 3. All right, what do you do with this one? Well, actually, this e, that natural log again, you could take the natural log of it. And then take the natural log of it after you got it by itself. So that would be e to the 0.015, e to the 0.015 t equals 3. Take the natural log of both sides, 0.015 t equals natural log of 3. And that's going to be 0.015 t times the natural log of e is equal to the natural log of 3. And that goes to 1. So 0.015t is equal to the natural log of 3. Divide by 0.015. Divide 0.015. T is equal to natural log of 3 divided by 0.015. Write these down, and you might want to write these down because of standardized tests. Sometimes a standardized test will ask you a question pertaining to double time. So just make sure you understand those three things. Here's an example. Facebook connects people with other members they designate as friends. During its period of heaviest growth, membership in Facebook was doubling every 6 months. What is the exponential growth rate of Facebook membership as a percentage? There you get R is equal to natural log of 2 over 6, which came from natural log of 2 over 6. Six months. And there is the rate, 11.6. So even though I won't test you on this, you might see a question in the homework, or you might see a question on the standardized test or an entry-level exam or whatever that asks you about double time. Be glad when we get to the dadgum calculus. Okay, solve. So this is just another review. 5 plus 7 natural log of x plus 3 equals 19. Well, the first thing is you got to get rid of that 5. So get rid of that 5 minus 5 minus 5. 7 natural log x plus 3 is equal to 19 minus 5 is 17. Divide by 7. Divide by 7. And that gives you natural log of x plus 3 is equal to 17 over 7. Now you can do the definition of a logarithm, because you've got log base e of x plus 3 is equal to 17 over 7. And the definition of a logarithm says y equals to log base a of x yields a to the y is equal to x. So that means e to the 17 over 7 is equal to x plus 3. So with that being said, I'm going up here. So a is e to the y, which is 17 over 7, is equal to x plus 3. And now x is equal to e to the 17 over 7 minus 3.
I think you did your subtraction wrong for the 19 minus 5.
Whereabouts?
19 minus 5 at the beginning.
Thank you. Thank you so much. Sometimes my brain is going faster than it needs to. Okay. So 12 over 7. So e to the 12 over 7 minus 3. Get your calculator.
It's supposed to be 14, not 12.
Huh?
So it's supposed to be 14, not 12. 9 minus 12.
Oh my gosh, I got 7 in my brain. I don't know why I got 7 in my brain. 19 minus 5 is 14. Thank you. Good gracious. And that'll be 2, right? E to the 2. E to the 2 minus 3 is equal to x. How about that? Good gracious. So e to the 2, thank you. Second, e to the 2 minus 3 is 4.38906. 4.38906. And it should be what they get. $4.389. Yeah, make sure you know how to subtract 5 from 19. It does help to know that 19 minus 5 is not, however many different numbers I said it was. If you ever become a teacher, you know exactly, or if you ever were writing something in front of people, you'll know exactly why teachers do what they do. Your brain is going and you're writing, and sometimes your hand and your brain doesn't equal out. All right, let's see, where are we? And that's pretty much it. Let's go to 2.2. Finally, derivatives. As I said before, you got to watch out for e to the x. E to the x is kind of like, oh yeah, that's easy. Yeah. And then you get 3 wrong on the test because you don't know really how to do e to the x. And what I tell students is, just disregard this. I tell students to rewrite it like this. F of x is equal e to the x, and put parentheses right there, and highlight those parentheses. Now, the derivative of any e to the x is going to be that e to the x. But they forget to tell you f prime of x is going to be equal to whatever this is. If this is negative e to the 3x, then you're going to put negative e to the 3x here. Whatever this is, it's just going to come right down. But they forget to tell you that if there's something in there besides an x, you've got to take the derivative of it. They forget to tell you that. And in this case, there's an x there. So you got to take that derivative. So f prime of x is equal to e to the x times 1. Now, I know all of you are saying, oh, well, that's easy. That's easy. Yeah. But you put a 1/2 up there or negative, and y'all will get it wrong every single time. So my final answer is f prime of x is equal to 1 times e to the x, or e to the x. Now, see, that is what gets you. And then you say your first day of logarithms or e to the x's, and then you get one like this. F of x is equal to e to the negative 2x. And you go, okay, that's easy. F prime of x is equal to e to the negative 2x. And then what? You get it what? Wrong. Because that's not the derivative of e to the negative 2x. So you go f prime of x is equal, you bring this down, e to the negative 2x, and you take your handy dandy pink highlighter and you highlight these parentheses right here that you should have had to begin with. And that means that I've got to take the derivative of what? Negative 2x. And then I rewrite it. F prime of x is equal, you just bring that down, e to the negative 2x. And then what is the derivative of negative 2x?
-2.
Negative 2. And now you've got the right answer. So the final answer of what you thought was real simple is negative 2 e to the negative 2x. And that's the correct answer. So we're going to do another one.
Hubert,
Yes, time to go.
I have to go to my next class. I can watch the rest on.
Okay,
Yeah.
but I'll try to keep up with y'all's attendance, but it's hard to do when y'all leave. You know,
I can write it in the chat too.
I still don't, and I'm not fussing at you. I still don't understand why people don't go to where they're going to class and call from there. But that's up to y'all. I'm not mad at you. I just don't understand it. All right, so I don't know who left, so somebody might have to. Who was that?
Megan Gammon.
Miss Gammon? Okay.
Yeah.
I hope I can remember.
All right, thank you.
All right, bye-bye. Let's see, what time is it? It's 3:38. We got a few minutes. I want to finish this e to the x. So if I give you f of x is equal to 1/2 e to the negative 3x, go ahead and do that one. F prime of x is equal to 1/2 e to the negative 3x. And then I take those pink parentheses and I turn them into orange parentheses. And I put that negative 3x in there. F prime of x is equal to, what is the derivative of negative 3x?
3.
Negative 3
Get 3 a minute.
times 1/2 e to the negative 3x. And of course, you can simplify that. That'd be negative 3/2 f prime of x is equal to negative 3/2 e to the negative 3x. Y'all want me to tell y'all what teachers do? Y'all ain't gonna want to hear this. But they will show you this in class. You with me? And they'll put these on the test. And you'll think you got 3 right on the test when you only got what? You only got this one right. Do you think they do that on purpose? They do. And they don't even show you, they don't show you the parentheses. I've heard teachers actually say, Oh, we'll just put the e to the x's on there. We'll just put 5e to the x's, and you'll get 4 wrong, and you'll get this one right. That's wrong. All right, there's 3 examples. Will you get 3 or 4 on my test? Yeah. And I bet you a bottom dollar they're going to have a negative or a fraction. Okay. Okay, there's 3 good examples, and we'll just close on this I'll just write them down for you, and I'm not going to be able to finish all of them. Y is equal 3e to the x. Y is equal to x squared e to the x. See, look at them. They're not, what they should do is give you x squared, and we're going to do that. That's going to be 2x. And the next one, C, is going to be y is equal e to the negative 2x over x to the third. So you've got 3 problems. This is the one that everybody will get right. This one, I changed that x to a 2x, and I changed this one to a negative 2x. So I'm going to do the first one for you, with you. So this one is not the chain rule. So y prime, you could do it as a chain rule, but I meant the product rule, but it doesn't matter. 3e to the x times 1, because this is in parentheses, and that'll be y prime is equal to 3e to the x. Got time for one more. Now I'm going to take my handy dandy, I'm going to put parentheses there, I'm going to put parentheses there, and I'm going to put parentheses there. Okay, now this one you got to do by the product rule. So y prime is equal to first times the derivative of the second plus the second times the derivative of the first. So y prime is equal to x squared e to the 2x times 2 plus e to the 2x times 2x. So 2x squared e to the 2x plus 2x e to the 2x. And you could factor out, I'm not worried about that. That's the answer. And I'm going to let y'all do that last one. And you should be able to work on 2.1 and maybe a few problems out of 2.2. Because we haven't finished 2.2. Capiche? Remember, I have extended your test one more day.